Oh, hi.
Hello there.
Do you have an odd taste in your mouth? Because I do.
You never know what he's going to say next. It's really good. The entertainment value alone, you got to admit, is really good. No. All right, so real quick one.
And Stoich.
Yeah, empirical formula, molecular formula.
We're being able to convert between one type of formula and another type of formula.
Yeah, and here's a little pictorial about what they really are, and we're going through them real quick.
Yep.
Right? An empirical formula is the simplest form of reduced.
Yeah.
Right?
Can't be reduced any further. All right. It's the simplest ratio of the elements.
Correct.
Within a formula.
Correct. And then the molecular is more the real world.
Right.
The real world molecule is multiples of an empirical formula.
If we wanted to go to breaking this down as to why this one's the real world molecule, we'd have to start drawing Lewis structures and all this other stuff to show that the octets for all of the elements are occupied, and we'd be showing at the same time for the empirical ones, they're not. Right. So the empirical ones are kind of like a busted down, simplified version.
It's like the units of the chain, and I can, like in organic chemistry, we can build these big old chains, right. But each one of these is a link.
Right, right. And while the whole chain is what's really useful, sometimes you do need to understand the simplest part of the unit.
If I'm going to break it down, what's it going to break down
into?
Right.
So we're going to convert molecular formulas into empirical formulas. How do you do this?
Simply reduce. Using the greatest
subscripts.
common factor. Yep. Reduce the subscripts. Yep. So let's do a few. Ready?
Can I write?
You can write. So here's a common glucose, C6H12O6. What is the common factor you see? And green is not showing up real well in there, but okay, there you go. I can divide all three of those numbers by 6. So that's going to give me 1 carbon, going to give me 2 hydrogens, and 1 oxygen. So we write that CH2O.
I mean, if you wrote it C1H2O1.
That wouldn't be against all the rules, but let's be honest, that would be doing too much.
Yeah.
Okay, next one. C4H8, reducing, looking for the greatest common factor in 4 and 8. I've got 4. I can divide both numbers by 4, and I will get 4 divided by 4 is 1. Man, you're good at this math stuff, loser. That's it. CH2 is the empirical formula.
And this is why this empirical formula doesn't really exist, because you can see here, hopefully, that carbon doesn't have 4 bonds to it. So while this is the simplest unit in the formula C4H8, it doesn't show us the real molecule.
Not even close. So, but it doesn't mean it's not useful. We still need to know it. So moving on. One last example, and we are done. I have 8 and I have 18. Can I get 9? I want 9 into 18, but I can't do 9 into 8.
4? 4? No.
They're both even, so we got 2.
Gotta have to 2. Sometimes it will just be 2.
Sometimes it will just be 2.
Mm-hmm.
So if I divide 8 by 2, I get 4. And 18 by 2 is 9. So C4H9 is the empirical formula of this bad boy.
Can't get any simpler because one's even, one's odd.
Nope. That's it.
Do it. And you can't ever have like fractions or partials or decimals in these. That's another thing.
That might have just been the shortest video of the unit. You're welcome.
You're welcome. Page 25. Find this greatest common factor for the subscripts. Divide all subscripts by it. Rewrite your new formula.
I got an idea. There might be 1 or 2 that's already the empirical formula to see if you're really paying attention.
N2O5. Can't do much with that.
Right. I don't know if that's a practice problem.
I think it is. Shh. Because the ones we're paying attention deserve it.
See ya.
See ya.